Good morning, students. Today we are going to start our new topic, that is definite integration. Exercise 7.9 from the NCERT textbook. All the integrations we have to do it as we are doing in the previous topics. The only difference is that after integration we have to now at last substitute that the limits given, lower limit and the upper limit. The substitution will be upper limit minus lower limit after integration. Let's see the first question. Integration I equals to minus 1 to 1. Lower limit minus 1, upper limit 1. X plus 1 dx. Suppose if there are no any limits, we are integrating in a simple way. Integration x plus 1 dx, we will get it as integration of x square by 2, x square by 2 plus x. As integration of x is x square by 2 and integration of 1 is x. After this integration, the only thing which we have to do it, that we have to substitute the upper limit and the lower limit in place of the x. So upper limit minus lower limit. Our complete function after integration is x square by 2 plus x. So upper limit is 1 square 1 by 2 plus 1. So it becomes 1 by 2 plus 1. Now upper limit we have already substituted. Now we have to substitute lower limit minus upper limit minus 1 का square positive 1 by 2 and minus 1 when we substitute here in place of x it will become minus 1 plus into minus minus. Now after substituting we will just simplify it. 1 by 2 plus 1 minus 1 by 2 plus 1 minus 1 by 2 plus 1 by 2 will be cancelled out and result will be our answer. Final answer is 2. Once again you can see integration of x plus 1 dx when it is given the lower limit minus 1 and the upper limit is plus 1. In this case of integration there will be no any integration constant, because integration constant when we are substituting the upper limit we are getting plus c, and when we are substituting the lower limit we will get it as a minus c, and plus c and minus c their integration constant will be cancelled out. So no need of putting the integration constant now here. So first we will integrate as we are integrating the functions x square by 2 x ka integration or 1 ka integration x. After integration in the complete function first we will substitute in place of x the upper limit and then minus, then we will substitute the lower limit in the function after integration. So x के जगह में पुट करेंगे 1 अपर लिमिट, तो 1 स्क्वायर बाई 2 प्लस 1 माइनस, अब माइनस अपर लिमिट का सब्स्टिट्यूशन हो गया, अब माइनस लोअर लिमिट क्या है माइनस 1, सो माइनस 1 का स्क्वायर प्लस 1 बाई 2 एंड हियर इट विल बिकम माइनस 1. आफ्टर सिंप्लिफिकेशन वी विल गेट आवर आंसर, फाइनल आंसर एज 2. In the same way you can solve the second, third, fourth and fifth, sixth question. Now question number 7, integration 0 to pi by 4 tan x dx. Here the lower limit is 0 and the upper limit is pi by 4. So integration of tan x is log sec x 0 to pi by 4. Upper limit pi by 4, in place of x we are going to substitute pi by 4 log sec pi by 4 minus now lower limit log sec 0. As sec 0 is 1, so it becomes log 1. Sec pi by 4 is root 2, and root 2 can be written as 2 to the power 1 by 2 in exponential form, and value of log 1 is 0. So as we know the log n to the power n is n log n, so this power will become the coefficient of it, log 2, 1 by 2 log 2, that is our answer. Now let's come to the question number 12. Integration 0 to pi by 2 cos square x dx. As whenever we are integrating cos square x, we are multiplying and dividing 2. So 2 cos square x 1 plus cos 2x by 2, 1 integration x cos 2x integration sin 2x by 2, and now we'll substitute the upper limit 1 by 2 x, upper limit is pi by 2 plus 1 by 2 sin 2 into x pi by 2 minus, now we'll substitute the lower limit x 0 sin 2 into 0 upon this 2. So 1 by 2 into pi by 2 becomes pi by 4. Sin pi value is 0. This complete function will become 0. So our final answer is pi by 4. Okay. I have given you the 7 properties of definite integration. Please go through all those 7 properties. It is very important in the further questions which I am going to solve through the videos. Now let's come to the next exercise 7.10. Now listen carefully here, there will be a slight change. Integration 0 to 1 x upon x square plus 1 dx. As in the previous topics we have done, x square plus 1, if we are going to take it as t, and this will be differentiated, so we will get the numerator function x dx. Let us see here, x square plus 1 equals to t लिए, x square का differentiation 2x, 1 का differentiation 0, 2x dx equals to dt, so we will get the numerator x dx will be equals to dt upon 2. Okay, but in case of definite integral, wherever we are assuming a function equals to t or any other variable, we at the same time we have to change these limits also. Don't forget to change the limits whenever you are taking any function stored to any other variable. So when x tends to 0, here the lower limit is 0. When x tends to 0, if I am going to substitute x equal to 0 here in this function which I have taken equals to t, so x की वैल्यू 0 रखिए तो क्या हो जाएगा, 0 का स्क्वायर 0, 0 plus 1 1, so then t tends to 1. It means that when the lower limit x tends to 0, then t tends to 1. And for upper limit also we have to change. When here x tends to 1, if we are going to replace here 1, 1 plus square 1, 1 plus 1 2, then t will tends to 2. Now when we are taking this function as equal to t, our limits also will be changed, both the limits, lower limit and upper limit. So our lower limit converted to 1 and upper limit is changed to 2. So now the limit becomes, as the x dx value is dt by 2 and this is t, dt by t, and lower limit is now changed to 1 and upper limit is now changed to 2. Now we can integrate with respect to t. So integration of dt by t log t. Now no need of changing the limits. Here now no need of substituting the value of t also here. If you are going to substitute the value of t as x square plus 1 here, again you have to change the limit. So no need of changing now the limit. In this same variable t, we will substitute this changed upper limits and the lower limits. So 1 by 2 upper limit 2 log 2 and lower limit 1 minus log 1, upper limit minus lower limit. So 1 by 2 log 2 as log 1 value is 0. Once again you can listen carefully. x square plus 1 को हम t ले रहे हैं, डिफरेंशिएट कर रहे हैं, x dx हमें dt by 2 मिल जा रहा है, लेकिन जहां हम किसी भी फंक्शन को किसी अदर वेरिएबल में लेंगे वहां हमें अपर और लोअर लिमिट दोनों चेंज करनी है. When x tends to 0, x की वैल्यू 0 रखेंगे तो t tends to 1 हो जाएगा. When x, here it is upper limit is 1, when x tends to 1, then t will become 1 square 1 plus 1 2, and then we will integrate with respect to t and we will substitute the upper limit minus lower limit, our changed limits. Okay. Now second question, integration 0 to pi by 2 under root sin 5 cos to the power 5 phi d phi. Cos to the power 5 can be written as cos 4 to the power 5 cos phi d phi. As we know that the differentiation of sin phi is cos phi. Now cos to the power 4 phi can be written as cos square phi the whole square. So cos square phi can be written as 1 minus sin square phi the whole square. Now let sin phi is equals to t. Differentiation of sin phi cos phi d phi equals to dt. So cos phi d phi will become dt. This will become root t. This will become 1 minus t square the whole square. Now come the case for changing the limits, because we have taken sin phi equal to some other variable. When phi is tends to 0, so sin 0 that is equals to 0, and when phi tends to pi by 2, that is sin phi by 2. Sin pi by 2, sin 90 is 1, so upper limit will become 1. Now by simple simplification, loss of exponents, we get integration 0 to 1 t to the power 1 by 2. First of all, you open this a minus b the whole square, a square plus b square minus 2ab, and after that you just multiply by the loss of exponents. You will get these powers, and then integration of x to the power n dx is given by x to the power n plus 1 upon n plus 1. With that you can just integrate all these three functions. You will get t to the power 3 by 2 upon 3 by 2. This constant value can be taken out of the limits. Okay, ये जो कांस्टेंट वैल्यू डिनोमिनेटर में आएगी 3 by 2, इसे हम कोफिशिएंट बाहर ले सकते हैं लिमिट्स के बाहर. Only the thing is that we have to substitute the upper limit and lower limit in variable part only, not in the coefficients, not in the constants. So 2 by 3 t to the power 3 by 2 0 to 1. So 2 by 11 I have taken out of the limit t to the power 11 by 2 0 1. Here 2 by 7 I have taken out of the limit t to the power 7 by 2 0 1, and after that upper limit minus lower limit, upper limit minus lower limit, upper limit minus lower limit, we get the simplification, and the final answer will be 64 upon 231. Now let's come to the question number 5. Integration 0 to pi by 2 sin x upon 1 plus cos square x. If we are going to take it as cos x equals to t, we will get the numerator function sin x dx. Okay, so let us take cos x equals to t. So cos x differentiation is minus sin x. So here it will become sin x dx is equals to minus dt. Now again here we have to change the limit. When x tends to 0, then cos 0 will be 1, t tends to 1. When x tends to pi by 2, upper limit, cos pi by 2 cos 90 is 0, then t tends to 0. So our limit now changes. So minus dt upon 1 plus t square, limit 1 to 0. So integration of dx upon 1 plus x square is tan inverse of x. So integration of dt upon 1 plus t square will be tan inverse of t. So minus tan inverse of t 1 to 0. So upper limit minus lower limit. As we know that tan inverse of 1 is in inverse trigonometry function we have studied. Tan inverse 1 can be written as pi by 4. So after opening the bracket we get the final answer as pi by 4. Now here comes to the next topic. It is the most important, properties of definite integration. Earlier also I have given you through the broadcast channel the properties. So please go through it. The first property is that integration a to b f of x dx is equals to integration a to b f of t dt. If we are taking a limit x is equals to, if we are taking a function f of x and f of t in a function variable x or in a variable t, both the limits will be equal. The integration parts will be equal. If we are interchanging the limits upper to lower and lower to upper, there will come one minus sign in front of the integration. Integration a to b f of x dx is equals to minus of integration b to a f of x dx. Third, integration a to b f of x dx can be written as integration a to c f of x dx plus c to b integration f of x dx, where this c value lies between this upper limit and the lower limit. Now the fourth property is, it is the most important property. Integration 0 to a f of x dx can be written as integration 0 to a f of a minus x. In solving further, many of the problems will apply this property. So be careful. Now fifth one, integration with both the limits are same but of opposite sign. Minus a to plus a f of x dx will become equal to 0. Its value will become equal to 0 if our given function is an odd function. An odd function is a function in which f of minus of x is equals to minus of f of x. And if the function is becoming an even function, that is f of minus of x is equals to the same function f of x, then it will be, this integration will be converted to 2 times of integration. Minus for a lower limit will become 0 and the upper limit will become as positive a f of x dx, and then we have to simplify it. Okay. Now the sixth property, integration 0 to 2a f of x dx. If f of 2a minus x, whatever the limit is given upper limit, if we are getting f of upper limit minus x function as an odd function, then its value will become equal to 0. F of 2a minus x is equals to minus of f of x, then the value will become equal to 0. Or if we are getting f of 2a minus x is equals to the same function f of x, then the upper limit will become the half, that is a. 2a ka half ho jayega a, and the integration will become the twice of it. Integration twice of 0 to a f of x dx. If f of 2a minus x equals to f of x. And the last seventh property, it is also the most important property. Integration a to b f of x dx is given by also integration a to b f of lower limit plus upper limit minus x dx. That is integration a to b f of x dx equals to integration a to b f of a plus b minus x dx. Now let's come to the exercise 7.11. Now the problems based on the properties of definite integration. The second question, integration 0 to pi by 2 under root sin x upon under root cos x plus under root sin x. Here sin x and cos x are complementary and complementary to each other. In the same way, sec x and cosec x are complementary to each other. Tan x and cot x are complementary to each other. As we know the definite integral property, fourth property, integration 0 to a f of x dx is equals to integration 0 to a f of a minus x. Here the value of a is pi by 2. So this can be written as root over sine a minus x pi by 2 minus x. This also cos pi by 2 minus x, sine pi by 2 minus x. So sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. So we get under root cos x upon under root sin x plus under root cos x. Now after applying this property, the question itself as our equation number 1 and this will be our equation number 2. We will add up these two integrations. So I plus I will become 2i. The limits are also must be same. Before addition you must see that the limits must also be same. 0 to pi by 2, 0 to pi by 2, and the denominator of both is cos x plus sin x root over sin x plus root over cos x. So when we add up these two right side, we will get under root sin x plus under root cos x upon under root sin x plus under root cos x. So the same term will be cancelled out. We are left out with 1 dx, and integration of 1 dx is x. So upper limit minus lower limit pi by 2 minus 0, as we are having 2i equals to pi by 2, so I is equals to 2 comes down here, pi by 2 into 2, that is pi by 4. Now comes to the next, it is a very important question. Now question number 5, it is the most important question. Integration 2 to 8 mod of x minus 5 dx. The modulus questions are the most important questions. Remember it, all type of modulus questions you have to solve it and practice a lot. So integration 2 to 8 x minus 5 dx, it can be taken x minus 5. This modulus function will be less than or equal to 0 on the interval 2 to 5. If I am going to take a value x equals to 2, 2 minus 5 will become minus 3, 3 minus 5 will become minus 2, and 4 minus 5 minus 1, 5 minus 5, 0. It means that if I am going to take x value from 2 to 5, it will be negative or equal to 0. And if I am going to take a value 5 to 8, then x minus 5, this modulus function will become positive. Okay, so this can be written as integration from 2 to 5. This x minus 5, this value 5 comes between the range of 2 to 8, between the lower limit and the upper limit. So from 2 to 5, this function, modulus function will become negative, and from the limit 5 to 8, this modulus function will become positive. Okay? In case of every modulus question, you have to justify for which lower limit to upper limit it will be positive function, and from which lower limit to the upper limit the given modulus function will be positive. So our third property of definite integration is integration a to b f of x dx equals to integration a to c f of x dx plus integration c to b f of x dx. So after integration, this will become positive 5 minus x. So 5x minus x square by 2, x square by 2 minus 5x. Now we can't cancel it out here, plus 5x and minus 5x, as here the lower limit and the upper limits are different. So be careful while solving it. So solve this function by substituting the upper limit minus lower limit. This function also upper limit minus lower limit, and after simplification we will get our final answer, that is 9. Okay, so be careful about this modulus function 5, which lies between 2 and 8, for which from which lower limit to the upper limit the given function will be negative, and also from which lower limit to the upper limit the given modulus function will be positive. That you have to justify the limits, and then only you have to solve the problem. Understood, all of you? Now let's come to the question number 7. Integration 0 to 1 x 1 minus x whole to the power n. So again we will apply the fourth property, integration 0 to a f of x dx equals to integration 0 to a f of a minus x. Here the value of a is 1. Okay, so a minus x, that is 1 minus x, 1 minus x whole to the power n. When we simplify, 1 minus 1 plus x, 1 minus 1 will cancel out. So we are left out with integration 0 to 1, 1 minus x, x to the power n. Now we can multiply x to the power n into 1, x to the power n, integration 0 to 1, minus x to the power n into x, x to the power n plus 1 by loss of exponents, 0 to 1 dx. Now, as we know that integration of x to the power n is x to the power n plus 1 upon n plus 1, so it will become x to the power n plus 1 upon n plus 1. This will become x to the power n plus 1 plus 1, so x to the power n plus 2 upon n plus 2. And now we will substitute the limits, upper limit minus lower limit. 1 to the power n plus 1 minus 0 to the power n plus 1 will be 0. 1 to the power n plus 2 minus 0 to the power n plus 2 will be 0. So 1 to the power n plus 1 will be taken as 1 only, so it will become 1 upon n plus 1. Here also it will become minus 1 upon n plus 2. After LCM simplification, we will get our answer 1 upon n plus 1 n plus 2. Now the question number 8, it is the most important question. Integration 0 to pi by 4 log e 1 plus tan x dx. So again we have applied the same property. Here the value of a is pi by 4. So log e 1 plus tan a minus x. So a is pi by 4, tan pi by 4 minus x. As we know that tan a minus b is tan a minus tan b upon 1 plus tan a tan b. So in the next step it becomes log e 1 plus tan a minus tan b upon 1 plus tan a tan b. And tan 45 degrees is 1, so it becomes 1 minus tan x upon 1 plus tan x. After LCM, 1 plus tan x plus 1 minus tan x. Minus tan x and plus tan x will be cancelled out. 1 plus 1, 2 upon 1 plus tan x. And now it is in the form of log m upon n. So log m by n is log m minus log n. So integration 0 to pi by 4 log e2 minus integration 0 to pi by 4 log e1 plus tan x. And integration 0 to pi by 4 log e1 plus tan x dx is the question itself. That is our I. So in the next step I am going to substitute here as I. So I equals to log e2, it is a constant value taken out of the integration log e2. Integration of 1 dx will be x, 0 to pi by 4 minus I. So transpose it, 2I is equals to log e2, upper limit pi by 4 minus lower limit 0, pi by 4 minus 0. So pi by 4 log e2, as this 2 comes down, it becomes pi by 8 log e2. Now let's come to the next question. 12th question, integration 0 to pi x dx upon 1 plus sin x. Again I am going to apply the fourth property. Integration 0 to pi x के स्थान पे अब यहाँ a क्या है pi. So pi minus x dx upon 1 plus sin pi minus x. 0 to pi minus x, as sin 180 minus theta is sin theta. So sin pi minus x will be sin x. On adding these two equations, I plus I 2i. Now x plus pi minus x. So plus x and minus x will cancel out, and this pi is a constant value, will be taken out of the integration. So we are left out with 0 to pi dx upon 1 plus sin x. So whenever we come across the integration of dx upon 1 plus sin x, we have to rationalize it. So 1 minus sin x upon 1 minus sin x. So a plus b to a minus b, a square minus b square, becomes 1 minus sin square x. That is cos square x. The same limit is going on continuation, 0 to 2 pi. Now 1 by cos square x is sec square x, and sin x by cos x will become tan x, and 1 by cos x will become sec x. So it becomes, here you see that pi will be multiplied 0 to pi sec square x dx, and this pi will be again multiplied to this term also. So pi sin x by cos x tan x, 1 by cos x sec x dx. So integration of sec square x is tan x, and integration of tan x sec x is sec x. Now after the integration, we substitute the limits, upper limit minus lower limit, that is tan pi minus tan 0 and sec pi minus sec 0. Tan pi 0, tan 0 value is 0, sec pi is minus 1, sec 0 is positive 1. So minus 1 and this minus 1 becomes minus 2. It becomes plus 2 pi, and this 2 and 2 will be cancelled out. So I is equals to pi. Now let's come to the question number 13. Integration minus pi by 2 to pi by 2 sin to the power 7x. Here we will discuss about the definite integral property. Integration minus a to a f of x dx will become 0 if the function is an odd function. So here our function is sin to the power 7x. So f of minus of x, if we are going to solve it, we are getting equal to minus of f of x. As sine of minus of theta is minus sine theta, so minus sine x to the power 7 will become minus sine to the power 7x. So f of minus of x is equals to minus of f of x. So the function, given function is odd function. So according to the property of the definite integration, its value will be 0. So our integration value is 0. Now question number 18, again comes the modulus question. Integration 0 to 4x minus 1 dx. Here the value of a is now here 1. So 1 lies between the 0 and the 4, between lower limit and the upper limit. So this function x minus 1 will be modulus function will be less than or equal to 0 for the interval 0 to 1, and it will be greater than or equal to 0 for the interval 1 to 4. So for this limit 0 to 1 the function will be negative, and for the limit 1 to 4 the function will be modulus function will be positive. And after justifying their limits we will simplify it and we will getting our final answer as equals to 5.